Hey everyone, welcome to KernelShield, a real-time operating system vulnerability detection framework. What you're looking at right now is our live dashboard. Over the next 5 minutes, we are going to show you how the system detects 3 types of OS attacks in real time. Everything you see here is live, no pre-recorded demos, no fake data. And now let's start looking at what we have on the screen. At top here, we have our summary metrics: total events detected, high risk events, medium risk events, and the time since the last vector. This big number is here. That's the health score. Think of it like a credit score for your operating system security. Right now it's at 100 because we haven't detected any sort of threats yet. And down here is our real-time event feed. Every attack we detect will show up here instantly with full details, severity, type, recommendations, and all. And these 3 buttons let us simulate different type of attacks. We have buffer overflow, trapdoor, and cache poisoning. All right, let's see it all in action. We'll start with the most dangerous one, the buffer overflow. Buffer overflow attack happens when a program tries to store more data than it's allocated to hold. Watch what happens when I trigger one. There it is. Look at this. The system detected it in 127 milliseconds, and let me show you what information we got. Vulnerability type, here it is. Severity score, here it is. Detection confidence, here it is. And look at this threat tier. See those indicators? Out of bounds, right? Stack corruption detected, memory stack violations. These are specific attack signatures our algorithm identified. And here's the best part: automatic mitigation recommendations. Enable stack canaries, activate ASLR, implement bounce checking. These are the real security measures used by the companies like Microsoft and Google. Notice the health score dropped. That's the system reacting to the severity of this attack. And now let's try a different type of attack, a trapdoor. These are hidden backdoors that bypass normal authentication. Detected. And you know what? This one's interesting. Severity, still high, but not as critical as the buffer overflow. Threat tier, still high, but still the same story. And look at the indicators. Hidden access patterns, privilege escalation attempted, unauthorized administrative operation, classic trapdoor signatures. And recommendations for this one are different. Review authentication mechanisms, order privileged access, scan for hard-coded credentials, and tailored specifically to trapdoor vulnerabilities. Health score now is at this. 2 CS attacks detected, and the system is still tracking both. Now, coming to the last one, this is when attackers corrupt the CPU's cache memory to steal data or slow down the system. Got it. This one is a bit less severe, and indicator says cache integrity mismatch detected. That's the system catching corrupted cache entries. And the fix: validate cache integrity, implement checksums, enable cache partitioning, and again specific to this type. Now look at our event feed. We have all 3 attacks logged with complete details. Each one has a timestamp, vulnerability type, severity score, and confidence level, along with specific indicators, detailed explanations, and mitigation steps. This comprehensive logging means that you can analyze patterns over time. Which attacks are more common? How does severity correlate with the system impact? All data is here. And now let's talk about the system health for a second. It's right now this, down from 100 when we started. This uses something called exponential weighted moving average. What that means is recent high severity events have the biggest impact. But over time, as the threats are resolved, older events matter less and the score recovers. It's like a credit score, but for your OS security. One bad event drops it, but good behavior over time brings it back up. And before we wrap up, let's look at the summary metrics. Total events, high risk, medium risk, and the time since we just attacked. Yeah, just now. And in real life production environment, if you see those numbers over hours, days, weeks, you could track trends and you can identify patterns like attack patterns and measure your severity posture over the time. And remember, all of this happened in real time. From the moment we clicked each button to seeing full analysis under 200 milliseconds. So how does this work? 3 layers. What you're seeing here right now, this dashboard is built with React. Updates in real time using WebSocket connections. Behind it, we have Python Fast API, backend running the detection algorithms, calculating risk scores, and generating recommendations. And all of the data is stored in SQLite database for historical analysis and audit trails. The detection algorithm uses real math, calculating anomaly scores, severity ratings, and confidence intervals, not just simple pattern matching. So that's KernelShield, real-time OS vulnerability detection with 91% accuracy, sub-second response times, and comprehensive risk assessment and actionable recommendations. We detect buffer overflows, trapdoor attacks, and cache poisoning. We log everything. We assess risk, and we tell you exactly what to do. All built with open source technologies, Fast API, React, and SQLite. No expensive licenses, completely transparent, so you can see exactly how it works. Whether you're learning about OS security, researching detection algorithms, or building production level monitoring systems, this framework gives you the foundation to learn. Thanks for watching. Questions? Check out the GitHub repo in the description, or maybe just put your questions in the comment sections. I will be really happy to answer all of them. Great day.